Hello, everybody. Here we are, 6.2, solving equations using algebra. The first 6.1 is a bit of solving equations with algebra tiles, and maybe I'll just draw them out for you quickly. I don't think we're doing with any x squareds, so let me just show you what an x tile looks like. That's an x. If it's a long, skinny tile that's shaded in, that's a negative x. And if it's a small square like that, that's a 1. And if it's a shaded in small square like that, that's a negative 1. And I'm recording this from home. My cat's here, so maybe you'll hear him in the background. And I guess like what I want you to know about algebra is that, algebra uses letters to stand in for unknown numbers that we can solve for using formulas and rules. And one of the main things that I want us to think about is we're pretty used to BEDMAS. And often if we're solving things algebraically, we're going to do the reverse of this. So we typically want to start with addition and subtraction and then move to multiplication and division. But for the first ones, we don't have any addition and subtraction, so we can just jump right to the division. So we want to do the opposite operation that is currently like being done to our x, or also known as a variable. Maybe I should say that. The letter is called a variable. Okay. Okay, here it is. Okay. Now he's on my lap, so maybe he won't yell so much. Here we go. So the x is currently being multiplied by 4. This is saying that 4 times a number, this is saying 4 times a number equals 32. So 4 times a question mark equals 32. And how we can find that is by doing the opposite operation. So we have 4x equals 32. It's being multiplied by 4, so we can divide it by 4. And what we do to one side of an equation, we always have to do to the other side of the equation. So we have to divide each side by 4. Remember, when we have a fraction, if we have 4 over 4, we have anything over itself, it just becomes 1. And we are left with 4 equals 32, or x equals 32 divided by 4, which is 8. And the cool thing about equations like this is you can always verify your answer. So you can say, is it true we just solved for x? So is it true that 4 times 8 equals 32? It is. So we know, like, for 100% certainty that this is the right answer. Okay, and now we have our next question. Here we have negative 35 equals negative 5 times x. So we have it reversed, but the order doesn't really matter. We just want to, it's currently, our x is being multiplied by negative 5, so we need to divide by negative 5. And what we do to one side, we got to do the other. So our negative 5s cancel each other, they become 1, and x equals 35, or negative 35 divided by negative 5. So x equals 7. Okay, let's do number 2. Now we do have kind of another step that's happening in our equation. There's in the grade 9 textbook, there's this kind of like metaphor that you can build an equation and then kind of like unravel it. So if you start with the a, the first thing that's being done to our a is it's being multiplied by negative 8. Oop. So our next kind of step, you can imagine we have a negative 8a. And then the next thing that's happening, it's being plus 11 to it. So in our next part, we have negative 8a plus 11. And then now, this is kind of like you can imagine our equal sign. We're going to undo this. So now we have our equals 27. So now we just need to do the opposite. So here we plus 11. You can think about minusing 11. And 27 minus 11 would give us 16. There we go. And now we have multiplied by negative x. So now we can think about the opposite as being divided by negative x, or sorry, negative 8. And 16 divided by negative 8 is negative 2. So that's a method that they teach you in grade 9, thinking about building the equation and then undoing it. And they make a metaphor of like it's like wrapping a present and then unwrapping it. So I don't know if that's a helpful method for any of you, but there you go. That's one more way to do it. Another way is to just think about doing the kind of like opposite operations that are happening to our variables. So currently b is being multiplied by 12 and there's being a 21 added to it. And we always want to start by kind of like our reverse order of operations. We want to subtract the 21 first. And we want our equation to remain balanced, so we need to subtract 21 from each side. So if you have a positive 21 and a negative 21, that's going to zero out, and we're left with 12b equals 92 subtract 21. That would be 71, and then 72. And now we have 12 b's is equal to 72, but we want to know what 1 b is. So we're going to divide by 12 on each side. And now this, remember, 12 over 12 is going to give us a 1. And we're left with b equals 72 divided by 12. So b equals, that's 9, isn't it? No, it's not 9. It's after the workday. I can't think. Divided by 12. 6. There we go. Equals 6. Okay. Let's do the next one. Solve each equation, verify the solution. Oh, we're supposed to be verifying the solution. I'll do it next time. So we have our 2x, subtract 7. Let's get the x by itself. So let's add 7 to each side. Now, negative 7 and a positive 7 is going to make 0. We're going to be left with 2x equals 9 plus 7, which is 16. Now, our x is being multiplied by 2. To get the x by itself, we need to divide by 2. We always want to balance our equation, so we're going to do it to both sides. And 2 over 2 just becomes 1. And we're left with x equals 16 divided by 2, so x equals 8. And now we can input our solution into the original equation and see if it's true. So we can see, is it true that 2 times 8 subtract 7 equals 9? So is that true? So 2 times 8 is 16. 16 subtract 7 is 9. So this is indeed correct. We can confirm that we got that one right. So let's do the next one. We have a negative 4x plus 6 equals negative 14. So let's start by getting rid of this positive 6. You can think about doing the same thing to both sides. I sometimes think about it just kind of moving over the equal sign and converting sign. So it's a positive 6. It's going to become a negative 6 once it gets over there. So then you have something that looks like this. Negative 4x equals negative 14 subtract 6. So negative 4x equals negative 20. And now we have negative 4 is being multiplied by x. We can divide by negative 4. I guess I'm using red. Negative 4 on each side. and we get x equals negative 20 divided by negative 4 is a positive 5. And then we can check our answer. Is it true that negative 4 times 5, I'm just substituting, I'm just inputting this value right here into our original equation. So I'm just taking this 5, I'm saying x equals 5, so I'm inputting the 5 value to where our x was. So is it true that negative 4 times 5 plus 6 equals negative 14? So negative 4 times 5 is negative 20. Negative 20 plus 6 is negative 14. So yes, we confirmed that's correct. Maybe I'll get you folks to try these on your own, and then we'll go over it. And I'll just do maybe this next one, just so that we're not going too long, and I can give you some help in person. So here we want to write an equation you can use to answer each question. Then solve the equation and verify the solution. So 5 more than 2 times a number is 17. Okay, so a number is our unknown. That's going to be our x. And we want 5 more than this. So it's going to be a plus 5, but it's also 2 times this number. And that's going to equal 17. So 5 more than 2 times a number is 17. What is the number? So now we can kind of do whatever method you want. You can kind of build the equation and then take it apart. You can think about kind of like converting this positive 5 over to the other side as a negative 5. Whatever you want to do. And let's do this one. So we got 2x equals 12. Then let's divide by 2, that x equals 6. Then we can confirm. Is it true that 2 times 6 plus 5 equals 17? So is it true that 12 plus 5 equals 17? Yeah, it is true. So we confirmed that to be correct. Let me do the next one. Then I can give my cat some attention. Now we have 6 less than 5 times a number is 29. So we have a number, and we have 5 times that number, and we want 6 less than it. So we want to subtract 6, and that's going to equal 29. So now here's another way we could think about it. We can think about balancing our equation. We're going to plus 6 here, and we can plus 6 over there. We get 5x equals, that looks like 35. Now we have 5x's equal 35, but we want 1x, so we're going to divide by 5 on each side. That becomes a 1, and we get x equals 35 divided by 5, which is 7. And is it true that 7 times 5, 35, subtract 6 equals 29? Yeah, it is true. So you can use that information to confirm your answer. Let's do the last question. So a grade 8 student had a graduation dinner. They paid a flat rate of $125 for the use of the hall, plus $13 for each student who attended. The total cost of the dinner was $944 students. Okay, so how many students attended the dinner? Write an equation you could use to solve the problem and solve the equation. So we have a flat rate for the hall is $125. We're going to pay that no matter what. Plus, we're also going to pay $13 per student. So this is like an equation for the cost. But we know that the total was 944. So now we can use this information to solve for the number of students who attended. So we did that, we did A, and now let's do B.